Hello and welcome to Erudite. In this video we're going to explore how to create this visualization of Viviani's theorem, which is a simple theorem that basically explains that no matter what point you pick in this triangle, the distance or the sum of each of the lengths, the orange length, the dark blue length and the light blue length, to each of the sides where they're perpendicular with the sides will not change. It will always stay the same. So let's close this down and code it up. So the first thing I have is two files here. One is just called viviani.py and the other is called trianglemodules.py. And both of these, they've got no code in them in a minute. They just have a little comment. This one says a program to explore Viviani's theorem. I don't know if I'm saying that right. I hope I am. And this one says modules to support exploration of triangles. Now we're going to be using Pygame, so we'll want to import Pygame into this, and we can just do some basic setup to begin with, where we just lay things out with the screen. So I'm going to have a width value and I'm going to set it to 800 and a height value which I'm going to set to 450, and we'll initialize Pygame. So we'll set a screen to Pygame display, and we want that to have a width of width and height of height, so that we can just alter these to shift things around. We can set a title for the window or a caption, and we'll call it lovely. Oh, I've done a rookie mistake. There we go, all sorted. And we'll initiate a clock as well, pygame.time.clock. Okay, that's looking pretty good. Let's get a background set up. So this is all just the basic things to lay out. And it'll want to cover the entire width and height as well. And I've got a bunch of colours that I've picked. You can of course switch them around as much as you like, but I'm just using RGB codes for these colours. We just need to set up our loop as well. So while true, we want to be able to shut the thing down. So for event in pygame.event.get, and this just allows us to basically access events that the user interacts with the program. So we just want to be able to quit. If you press quit, that it'll actually allow you to shut out of the program. Pygame.quit, and then we'll exit. Okay. That means I do also want to import from system imports exit as well. Okay. How are we doing here? Oh, and we will eventually want to import the triangle modules as well. We need to use Blit to actually show our surface, or our background in this instance. And then we'll just do a simple display update and tick, and we'll set it to 60 frames a second. Okay, let's just see how this looks for our background setup. So Python viviani.py, and we should just see a plain background once it's finished. There we go, a nice light grey background. Okay, what we need to do is define 3 points so that we can draw the lines to create a triangle. And I've already worked these points out considering the width and height that we're dealing with. So I'm just going to define them as tuples and xy. Tuple of 150, and this is going to be an upside down triangle because Pygame it initializes 0, 0 position at the top left hand corner rather than the bottom left hand corner, which can be quite counterintuitive, and we'll see how that messes something up a little bit later and then fix it. 396 and point C is equal to 550. So you can see how A and C, they're 100 apart at the same Y value, so that's that straight line. And then at the midpoint, so in the middle of this, we then have a point further away to just create a big triangle like that. We'll want to use the Pygame draw function to create those. So we'll say pygame.draw.line, and it wants to be on the screen. The color I've picked for this is just a nice dark blue, I think, and we'll use point A. We want to go from point A to point B, and the thickness of the line we'll set as 5. We'll just copy that and do that twice over, and we'll just change that to B to C and C to A. And if we run that, we should get a nice triangle. There we go, we've got our triangle in place. Beautiful. Now what? If we have a quick look at this triangle, there's a couple of things we're going to need. First thing we're going to be able to, or going to need to do, is to tell when the mouse is actually within the triangle. And what we're going to want to do is compare the area of the triangle. So if this was the point here, there would be a triangle like that, and like that, and like that. And the area of those three triangles would equal the total area of this triangle. But if I'm outside of here, the triangle I make between those 2 points and between those 2 points and so on would be greater than the area of this triangle. So only when it's equal will my mouse pointer be actually inside this triangle. So we're going to need two functions to carry out this check. We're going to need one that allows us to determine the area of a triangle, and we'll need one to determine whether the total sum of those areas is equal to the area of the large triangle. So let's start by defining a function for calculating the area of a triangle, because we're going to need that in lots of these other functions. And we'll just call it triangle area, and it'll accept 3 points, which are the 3 points of the triangle. So point 1, point 2, and point 3. And for the time being, we won't do anything with this, but we're going to be using a formula called Heron's formula. And you can look that up. You'll see how we implement it in a second, but I've just remembered we also need to pull in a function that we wrote in a previous video for Euclidean distances, because we're going to need to measure the distance between 2 points, and I believe we wrote this up in the KNN video. So if you want to find lots of detail about this one, you can find it there. It's basically using the Pythagorean theorem to calculate the distance between 2 points in n number of dimensions. So for I in range, and it will just be the length of a point, and you iterate that point, carrying out subtraction of them, and we don't need to get the absolute because we're going to square the value. like so. So it'll always be positive. And then we want to return the square root of s. And that'll just give us the distance between any 2 points that we pop in here. So now we've got that set up, we can continue to have a look at this, where we're going to calculate the 3 sides of our triangle. And we're going to use our function. We're going to get sides 0.1 and 0.2. And we're just going to copy this, and we'll get the other 2 sides of the triangle as well, so that we have all 3 sides, or the distances, for all 3 sides of our triangle. That can be 2 and 3. This can be between 3 and 1. And then what we're going to do is use Heron's formula, where we define a value of s, and it'll be equal to side 1 plus side 2 plus side 3 divided by 2. And the area will be equal to that s value multiplied by s minus side 1 times s minus side 2 times s minus side 3. And we need to take the square root of this as well. And all this code will be on GitHub if you want to check through it or use any of it. And then we just return the area value. So this gives us the area of our triangle. And now, not like that. Now we want to write a function where we take this area, and we can use this area function to measure the areas of the triangles from our point, where our mouse might be, to each corner of the triangle, and then see if the sum of those 3 triangles equals the sum of equals the area of that large triangle. So let's write a function that we're going to call inTriangle, and it will return a boolean, true or false, which will be dependent on whether we're in the triangle or not. So if we're in the triangle, it will return true, otherwise it won't. So area main, that's going to be the area of the triangle that's the large triangle. And then what we're going to do is get a set of areas, just like we did with the sides, for each triangle. So point 1, point 2, and point P. And then we're going to copy this and make it for 2 and 3, like so. And we'll just swivel these around. We're always going to need point P in there. There we go. So we've got the areas of our 3 smaller triangles, and we can just get an area sum value, which will be equal to area 1 plus area 2 plus area 3. And we basically want to say that if no, we'll just carry on with it for now. If we say if area sum is equal to area main, return true, else return false. Now this condition is going to cause us some problems, but we'll have a look at that and see what it does. So let's save this file, head back over to here, and we'll test it. So we want to make a function in here, not a function, sorry. We want to get our mouse position, so we're going to say mouse check is equal to pygame.mouse.getPosition, and if we're importing this from triangle modules, in triangle, so we can use that function, point A, point B, point C, and our mouse check, because that returns a point as well, So if this returns true, print inside, else print outside. Okay, that looks good. It's just a quick check, and what we'll do is see how that works. So let's let's save this file first, and then let's run that and see what happens. So we're outside at the minute, and did you see we go inside sometimes? Can you see how it's... And that's because it's not always exactly equal to. The float means that there's a slight error in this. So I'm just going to do something to remedy that in our module. Let's just tidy that up. And what we're going to do is, rather than say if area sum is exactly equal to area main, we're just going to set some limits instead. If area sum minus 1 is less than area main and area sum plus 1 is greater than area main, so effectively we're just creating this small domain that float can fit within. And if we test that, let's save that. And we'll run this again. So you can see we're outside, now we're inside. Inside, outside, inside, outside, inside. So it's actually very sensitive, it's working really nicely. Okay, lovely. So we're able to tell when we're in the triangle. Lovely. And just for a bit of fun, we can take our point P. Let's actually define the point P. We'll initialize a point P, and then we can move it with the mouse once everything starts up. So we'll say point P is equal to 300 and 165. If it's inside, we'll want to update point P will equal mouse check. We can get rid of this because we don't really care if we're outside the triangle anymore. And that's alright, we're just doing that update dependent on whether we're in the triangle. But let's draw some extra lines just to be, you know, a bit interesting and to see what's going on. So we'll copy and paste this section here, but we're going to make it a bit dynamic instead. So we'll say, we'll just make this a simple color. We'll basically go from each of the corners of the triangle. So from point A to point P, from point B to point P, and from point C to point P. And we'll make it a bit smaller. We don't want great big thick lines doing this. This is just to have a bit of fun and see what things look like. So let's run that. So you can see that where we initialized our point P, it's in the middle of that triangle. It's not going to change as we move the mouse around outside this triangle. But when we move the mouse into the triangle, there we go. We're able to change that point. We've got this nice bit of dynamic motion. Let's crack on with trying to calculate these height sections. So we don't need any of this anymore. That was just a bit of fun. And get rid of that. And we'll tidy up the terminal. So what we're going to want to do is now write a function that will allow us to determine the height of a triangle, because what we want to do is measure that perpendicular height between our point P and each side of the triangle. So let's just pop over here, and in fact finding the height is super easy, because once you have the area, you can use the really simple equation of a half base of the triangle times the height to get the area. So we can go back and work out the height will be equal to the area divided by a half times Euclidean distance between 2 points. So let's get our triangle height from triangle height point 1, point 2 and point 3. That's for our triangle. The area will be equal to the triangle area of these points. So we'll just pop that through. And the height will be equal to the area divided by 0.5, so that's our half, times the Euclidean distance between points 2 and point 3. Now it's really important to notice that this will give the difference, the height between the base surface that is between points 2 and 3, going from that perpendicular to that base to the top of the triangle, and we'll return h like so. So as we're initializing the point here in the middle of the triangle, we also want to initialize the heights of the triangles, those that form perpendicular to the sides of the larger triangle. Those heights, sorry. So I'm going to call them alpha height. Well, we could just call them beta height and gamma height. And in order to get them, we can look at 165 minus 50. That gives us, they'll each want to be 115. And now we can use these to also update when we're inside the triangle. But we want to create those lines to the sides. So we need to figure out where the points are, because given alpha height, we know that from point P, a line that's 115 long will touch one of the surfaces, one of the sides, at a given angle. And this is where I mucked it up when I was practicing this, which was to do with getting the right angle on a point. But in order to draw the line, we just want to get the point. So we're going to need to write another function called getPoint, and we'll use that to find the point that we'll draw our line to. So let me write a little bit of code here. We're going to want to use pygame.draw.line again, and we're going to draw on the screen, and I think 174360, the first one, and we'll just call it alpha. We haven't got that point yet, we don't have that bit of information, and we'll go from alpha to point P, and we'll make that line about 3 thick, and that will give us that one of the lines that goes from the point perpendicular to a side. Okay, but we don't have this point yet, and we want to get it. So we'll write a function that says alpha get point, and it will take point P, because we want to know where that point is in relation to point P. We'll need some angle from point P to go, and we'll need to know the height, so we'll say alpha height. So let's just drag this over to our modules and define it. We'll say point, angle and height. Though actually really it should just be length, because it's the length of the line. We're just calling it height because of the triangle aspect. I'm just going to convert the angle because I'm going to provide it in degrees, but I'm going to convert it. I want to import math, so let's just do that. Let's import math. And what we're going to do is use this angle to create the next 2 points. So x will equal point P, and that will be 0. The 0 index is the x value, plus, and we're going to have our length times, we're going to use the cosine of the angle. That's for x value, and our y value we're going to use the sine. It'll be at position 1, and there's a sine. Okay, and then we'll just return a tuple, which is x, y. So that's sending a point back that we can then use. We need to make sure that this is coming from triangle modules dot get point, point P, angle, and alpha height. And this is where I messed up, because I was trying different angles, and I thought, oh, okay, so if I tried 90 degrees, it would go straight up. Let's see what happens at 90 degrees. Point P is not defined. Because I just point and point. There we go. So when I did 90 degrees, oh, it's because point P is moving. I've mucked it up. We'll get back to this in a second. When I did 90 degrees, it was pointing straight down. So I realized that I actually need to rotate everything, because just like the 0, 0 is here instead of here, when I do that transformation, it's effectively doing it in the wrong direction. So if I change this to 270, which is the flip side of 90, we should get it pointing straight up. Yes, there we go. So it's pointing straight up. Beautiful. Lovely. Okay. Now, when we do this, you can see it's not moving. It's not altering dependent on how far away I go from there. It's always staying the same length. And that's because alpha height here is not updating. So we need to update alpha height. And we'll do that here. So alpha height will equal, and we can use our triangle height function that we had before. So triangle underscore height, and it will be between point P, I think it's point A, and point B, but I just want, so point A and point B, are they the top two? Oh, it's because I did this angle wrong, as this is meant to be one that goes to alpha is, yeah, alpha is between A and B, that was the whole point. But 270, so we need to go back 120, because it's the triangle, 120 degrees, remember? Which will put us at 150. So now, if we run that, okay, so you can see how it's altering. When we're in the triangle, that length is changing and suiting perfectly. But when we go out of the triangle, it stops. And then we're in. Lovely. Okay, so that's working really, really nicely. Let's add in the other two lines, which will just be a simple, almost copy and paste job. So alpha height. beta. Let's just check that that's all working. So we've got that triangle in the middle, and then as we move around, each line is changing. Beautiful. Okay, that's working. Let's just sort those colours out, because that's a nice easy fix, and it makes a bit of a difference. Okay, so that's looking really, really nice. It's already quite easy to see how when one line gets smaller, the others compensate by getting longer or such. So we're able to see a really nice aspect of this theorem. But we want that visualization at this side here, which is sort of the stacking rectangle showing the height doesn't change. So how are we going to do that? Well, we're going to use some rectangles, and we'll do them here. Pygame draw.rect screen, and I want the same colours. We'll come back and do that in a second. We're going to need to... Right, I want it to be 600 across, because that should shove us well out the way of the triangle. And then we need to do the top of the rectangle. So the triangle is 396 tall. That's the height of the large triangle. So if we do 396 minus the alpha height, that means the top of the rectangle, yeah, that'll be great. The top of the rectangle will be alpha height away from the bottom of the big triangle. So that'll be the right position to put it. We'll check all this, don't worry. And I want it to be 50 wide, and of course it's going to have alpha height as its height. Okay. And the colour, we want it to be the same colour as this. Let's just add a comment in here as well. I'm sorry that everything keeps going off the side a bit. It's when I do the big font, so it's easier to see. Can't always fit as much in the screen. All of this will be on GitHub if you want to check through it and have a go. So let's just see how that one behaves. So it starts out, right? Yep. And then if we make it really, really long, if we make it so the others are tiny, yep, it's almost the height. Beautiful. And if you make it super small, lovely. So that's working. We just have to stack the others on. And I think I'm going to do this really badly. We're just going to carry on with this and stack a few subtractions on there. It's not very pretty. If you can think of a nicer way to do it, let me know, and I will happily change this. I mean, it'll work, but it's just not the prettiest thing ever. Just changing the colours. And for this one, we're going to want to also take away the beta height. And it will only have the beta height. Lovely. This will be gamma height. But we'll have to take them all away. This is not looking pretty. I'm half tempted to pull these rectangles out into their own thing. Well, let's run that first and check that it's all working nicely. Oh, typo. Okay, and there we have it. That's a nice little representation of the theorem, where you can see that this overall height isn't changing. It stays the same. It doesn't matter where we go in that triangle, the sum of the lines from that point perpendicular with each side of the triangle is always the same. It's a really, really nice way of just representing it. Thank you so much for watching, and I hope you enjoyed this one. I've really enjoyed exploring how to visualize algorithms using something simple like Pygame, and I think I'm going to do a few more videos like this. So if that sounds fun and something you'd be interested in, why not subscribe to the channel, and I hope I see you in the next one. Bye!